welcome back to Module 8, ladies and gentlemen. I know Module 8 on your course text is related to sort of carbohydrates and fats, but within this video we're going to look a bit more about metabolic pathways. Okay, so we've discussed some metabolic processes when we looked about the Krebs cycle and things like that as well, but I just want to discuss them in a little bit more depth and make this a bit more focused around the sort of typical nutrition questions that you might get asked. Okay, so in this one we're going to define the terms relating to the different metabolic pathways. This is a bit of revision really. This is a chance to sort of really absorb this information and understand what different terms mean, which, like I've said before, a lot of science is a language, so understanding what these sort of scientific terms mean is going to help you kind of interpret papers or interpret articles that you might read. I'm going to talk a little bit about the formation and breakdown of glycogen, and so how carbohydrates are stored. I'm going to talk a bit about carbohydrates and fat storage as well, so what happens to fat after eating it as well, and can fats make you fat is a big question that I've actually seen some quite reputable people suggest that they can't, so we'll talk about that a little bit as well. And I'll talk a little bit about can excessive carbohydrates be stored as fat and mechanisms by which this take place, and I'm going to talk a little bit about the insulin hypothesis as well. I think I've mentioned it briefly before, but the insulin hypothesis basically suggests that people, you need to control insulin to be able to lose body fat, and insulin is the key driver in body fat loss. And there's some merit to that argument, but it's not quite as cut and dried as you may think. The first thing we're going to start off with is these metabolic pathways. So we'll talk through each of the different nutrients and look at how they interact. And we've talked a little bit about this previously. Like I say, we did the pathway with the Krebs cycle, so this is a bit of revision, but this is an important time to really grasp this if we're going to talk about fat storage and so on and so forth as well. So if we look at our blue words there are nutrient sources or macronutrients. So we've got carbohydrate, lipids and proteins. So if we start with carbohydrate, carbohydrate is obviously broken down initially into glucose. Okay, so then that goes into glycolysis, which then produces energy. We can also have glucose that's in excessive amounts be converted through the process of glycogenesis into glycogen. Okay, so glycogenesis, any word with the word genesis at the end of it usually means a building up of a material, and enolysis or olysis would be breaking down a material. So if we look at glucose, once it's been formed from carbohydrates, it's digested and absorbed, it's got a couple of fates. It can either go to glycolysis directly for energy, or to produce glycogen through the process of glycogenesis. Then glycogen, when it's needed to produce energy, is broken down through glycogenolysis. So that could be within the muscle tissue or liver. Okay, so glucose as well, if we've got excessive amounts of glucose, or weirdly if we've got a low amount of fatty acids in the diet, our body needs to produce fat. So actually glucose can be converted to fatty acids when they're needed in the body as well. So it's not just about energy intake and high carbohydrates. The body will actually shuttle carbohydrates to produce fatty acids if we're on a particularly low fat diet, so we're not getting enough essential fatty acids in there. We'll talk about some of those processes, how it does that in a little while. But then, so glucose can then be converted to fatty acids through fatty acid synthesis. Okay, so if we then move down onto our lipids, we can see that lipids are broken down in digestion to fatty acids and glycerol. Now, fatty acids and glycerol can then be used for fatty acids will then be used for fatty acid oxidation, which then partly releases energy to regenerate ATP, partly then enters into the Krebs cycle as well. Or it can be through the process of lipogenesis or lipogenesis, can be then used to create adipose tissue or fat tissue. Again, that would be the fat equivalent of glycogen. Then through the process of lipolysis, this is the breakdown of stored adipose tissue to produce fatty acids for oxidation, and glycerol for gluconeogenesis. Okay, so our fatty acids can be stored in adipose tissue through a process called lipogenesis. Once it's in adipose tissue, it's broken down through the process of lipolysis to produce those fatty acids again that the body can use to produce energy. From that, we've got our glycerol as well. So we've got our glycerol backbone, which is also broken off. So I've just drawn that separately underneath the fatty acid oxidation because it sort of comes from lipolysis as well. We then have glycerol, which can then be used to produce, through the process of gluconeogenesis, glucose again. So this is one pathway from using from using glycerol. So from fatty acids, we can actually, not fatty acids, apologies. So from glycerol, we can actually generate glucose from non-glucose sources. Okay. Now, if you look on that pathway up to gluconeogenesis on the right-hand side there, you'll see the big red line. That's the point where basically the body can't synthesize glucose enough from non-glucose products, and that will lead to the state of ketogenesis. Okay, so when the body is reliant on ketone bodies to provide some of the functions that glucose can, if glucose can't be provided in an abundant enough supply. So then if we go to protein, protein is then broken down obviously in digestion and absorption to amino acids, or the term proteolysis there is the breakdown, would typically be applied to the breakdown of proteins within the body. So muscle tissue being broken down for energy would be proteolysis. Again, olysis, breakdown. Now amino acids, once they're digested and absorbed, comes in two types. Okay, so we've got glucogenic amino acids and we've got ketogenic. As the ketogenic amino acids would suggest, those can be used to produce ketone bodies. Glucogenic, as the name would suggest, can be, through the process of gluconeogenesis, be used to produce glucose. Okay, so this is an important thing because we obviously need some background of glucose there. So if you look at the other pathways, even though we're not necessarily eating carbohydrates in the diet, if we ignore that one because it's not an essential nutrient, you can see that actually if you've got adequate amounts of lipids in our diet, and particularly if we have an adequate amount of protein, because many of the amino acids, I think in the module text it tells you which ones are which, many of your amino acids are glucogenic as well. So if you have too high a protein diet, it means that you're probably not going to go into ketogenesis. It's something that you know, a lot of people, when they test to see if they've gone keto, if they're using that style of diet, they tend to find that if they've got too high a protein amount, then that's not going to be the case. That's why they suggest you keep your protein levels at around about 30% of your intake, I think. I wouldn't advise that. 70% fat diet, or pretty much 70%, is particularly a positive thing. But if people do use a ketogenic diet, then be aware that, you know, too high a protein will stop you going into ketogenesis. Why that's an outcome that we strive for is sort of beyond me, to be honest. It just means your body's using more fatty acids for energy. It doesn't have anything to do with energy balance directly as such. Okay, so we've dealt with some of the pathways there. So take a minute to maybe pause that and absorb those terms. So your olysis is, your genesis is. The only one that's really different is your sort of fatty acid synthesis there. And yeah, so those are the terms that will get you from A to B when you talk about metabolic pathways, or you're looking at those articles and things that you might want to understand what's going on. Okay, so now we've dealt with glycogen synthesis and breakdown. So what happens when we do get to that point where our glycogen levels are full? We can synthesize fatty acids from this point. Like I said before, this is from excessive amounts of carbohydrate intake, and I'm talking serious amounts of carbohydrate here as well. If fats are kept low, so energy balance is still moderate to high, you know, the studies that have shown 800 grams of carbohydrates plus won't lead to fat deposition, assuming that your energy levels from your fat intake as well are quite low. Okay, so but if we are in that situation where someone has got excessive amounts of carbohydrate in the diet, okay, this basically it generates fatty acids from excessive input into the Krebs cycle. So when we go into the Krebs cycle, if you think back to the module where we covered that, there's a molecule in there called citrate. Okay, it's an intermediate. Now, as we've said, pyruvate can't be acetyl-CoA, once we're into the Krebs cycle in the mitochondria, can't be converted back into pyruvate, okay, or pyruvic acid. So the only way we can get energy out of the Krebs cycle is through this intermediate called citrate, which is on there. So check that text to see that, and also check in your textbooks if you've got those, or check online to see where it falls into. And this conversion takes place primarily in the liver, okay? So the key intermediate is citrate, and that is exported from your mitochondria into the cytoplasm. So citrate is a 3-carbon compound, so you see there it's got the CCC, and this is converted back into oxaloacetate, which is a 4-carbon compound. Then what happens in the mitochondria is, with the addition of a little bit of energy, which we've got in there, we create a series of a 16-carbon compound called palmitic acid. So that's all taking place in the liver. From this in the liver, this is then exported, packaged as we know, into our lipoprotein carriers, and this is transported around the body then to be stored as fatty acids, okay, in our adipose tissues as well. Okay, so that's how we can get excessive amounts of carbohydrate to fatty tissue. We also might actually get fatty acid synthesis when there's a lack of fatty acids in the diet, because obviously the body needs to generate fatty acids for cell membranes and so on and so forth, like we've discussed. It does a whole host of other things. So sometimes, even if carbohydrate intake is moderate and our fat intake is very low, we might need to synthesize fatty acids in the liver for the functions that fats play in the body as well. Okay, so there's the two main sort of situations where your body will need to generate fatty acids from carbohydrates. One is if there's an excessive amount for storage, and the other is if there is a lack of fatty acids within the diet, therefore the body needs to generate them. Okay. So the insulin hypothesis, and I know I'm repetitive on this one, so I do apologise, but I think it's a really important one to hit home. And these are the sort of main bullet points I'd like you to take away with you on this one. Okay, so insulin stops fat burning. Okay, yes, but only at an individual cellular level. That's an assumption that insulin binds to a fat cell. Okay, not all the insulin you release is going to bind to all of your fat cells in the body. Okay, so not all fat cells are going to have exposure to insulin at any one time. However, larger releases have the potential to stop lipolysis, or at least make lipolysis less efficient. So like I say, if you have poor insulin sensitivity, or you have someone who has carbohydrate sensitivity, as people would like to cause it, yes, they're not going to be losing as much fat because of that. Okay, but carbohydrates and large amounts of fat, and its general overconsumption of calories are the issue. So if you've got someone who's got poor insulin sensitivity, okay, it's probably because they're overweight in the first place. So reducing calories overall after a period of time will help improve their insulin sensitivity, as will resistance training as well. A lot of the proponents of these low-carb diets will still be relatively high in protein, but remember, protein releases insulin too. So I don't understand why people have this phobia of carbohydrates, but not of protein. Okay, protein releases insulin. It's not quite as insulinogenic as carbohydrates. So what is the issue then? Well, protein will obviously release insulin, but it doesn't raise blood glucose levels. It's not contributing to energy in as direct a way. Okay, so that's why protein doesn't have the same impacts as your carbohydrates and fats in terms of fat storage or fat release. Okay, so the key to all this, from my understanding of it, and feel free to go and read about this stuff and disagree with me if you want, is that the key appears to be control of blood glucose. Okay, so we don't want big insulin spikes all day long. We don't want big spikes in blood sugar all day long. Why? Because we know that fluctuations are going to impact on thyroid function. They're going to impact on energy levels. You're going to potentially, by having larger releases of insulin, affect insulin sensitivity as well. Some studies will point to the fact that in diabetics, so a recent study I was looking at on type 2 diabetics, showed that actually having smaller meal frequencies actually improved insulin sensitivity, but they were doing longer periods of fasting. Now, as we know, fasting might improve insulin sensitivity as well. So there's certain populations where this doesn't hold true. However, most of us aren't going to be dealing with people who are type 2 diabetics, okay? Or if they are, fasting protocols can be effective, but I still hold true that controlling blood sugar controlling blood sugar can be done through maybe keeping lower amounts of carbohydrates in the diet, but still allowing yourself to eat protein and fats, throughout the day to actually maintain energy, to actually optimize protein synthesis as well. So yes, things like intermittent fasting do have some evidence to suggest they improve insulin sensitivity. However, we've got to think in terms of what our goals are with our clients. Are we going to sacrifice that for optimizing protein synthesis? We're going to sacrifice optimizing protein synthesis for that, when we could just maybe keep carbohydrates out of the diet in the daytime, and keep them around training initially, and then introduce them as weight loss improves and sensitivity improves as well. Okay, so we need enough carbohydrate to support recovery and performance as well. So bear in mind, we're in a performance-based industry, and if you're not progressing in the gym in terms of your weights, your strength, so on and so forth, you're not going to be building muscle tissue. So yes, it's not having an excessive amount of carbohydrates, but you're going to need enough to restock yourselves, and that's going to be more the bigger you are. It's a simple correlation, it's causation and correlation really. Bigger people have more muscle tissue. Well, more muscly people have more muscle tissue, obviously, so therefore you're going to need more carbohydrates in order to restock those things. So these are things to consider, okay? And these are things you consider for your clients. You're never going to give someone who's 100 kilo, 4% body fat bodybuilder, like 200 grams of carbs a day to restock glycogen if they're doing heavy leg sessions. It's just not going to happen. And whereas for some people that might be excessive, and don't forget, leaner people tend to have better insulin sensitivity as well, so you might get away with more carbohydrates in someone who, even if they've got the same muscle mass as someone who's maybe heavier because they've got more body fat, bearing in mind that smaller people, leaner people tend to have better insulin sensitivity, so they can get away with a little bit more carbohydrate in the diet perhaps. Obviously we can control the blood glucose with meals with fats and fiber. Fats will slow and blunt that insulin response, okay, and it will blunt it massively. So we can still get our carbohydrates into our body, still producing energy, still allowing our muscles to recover, But with those fats in there, like I say, it'll blunt that insulin response. I think it's even with just pure glucose, 30 grams of fat will blunt the insulin response, the peak insulin response, in about half, okay? So we can do that to control blood glucose. If we can control blood glucose, we're not going to get big releases in insulin. So although we're getting all the benefits of having carbohydrates, we're going to really restrict the negatives that are associated with it as well. Like I say, if insulin is released, it's going to, cell signaling is going to make it want to bind to those receptors that are on our fuel cell empties, okay? So if we imagine our muscles are empty because we've trained them, they're going to be heightened and ready to bind to insulin. So, the chances of it getting to even adipose tissue to bind to are going to be slim to none if we've got a depleted, trained individual there as well, or a depleted individual. So, those sort of things there. Meal frequency, I've put a question mark next to this because, like I said before, in certain populations, meal frequency seems to be able to control blood glucose. So having meals little and often, well, obviously you're not going to have as much carbohydrates, so you're going to keep your blood glucose at a lower level, which is going to give you, overall, if your insulin sensitivity is okay, a more appropriate insulin response. However, like I said, in certain populations, less meal frequency and more fasting periods might be of benefit, although as a general rule, for most people, I would steer clear of that, like I just explained before. But actually, a lot of studies now, when we look at meal frequency, they'll say there's no difference in terms of metabolic output. However, what I will say about this, and I'll keep it quite broad because I don't want to be too committal on this in case things change, because science has a way of doing that, is that a lot of these studies are done on inactive populations. The 2 or 3 studies I've seen on healthy populations where they look at meal frequency actually suggest that by increasing meal frequency, people preserve more muscle tissue and lose more body fat. And I theorize, purely my theory, that this is due to the fact that blood glucose levels and energy intake levels at each meal are lower, so you're not going over a threshold which is going to actually inhibit fat loss as well. So if you think you're eating all your meals frequently and you've got a certain amount of calorie intake you can have per hour until the body's going to need to store some of that energy, if you can keep yourself spaced apart, you're going to very rarely go over that threshold where the body's in an excess energy intake. Whereas if you eat less frequently, yes, you might be lower through the other periods of the day, but you're going to actually have periods of the day where your body and your blood glucose is high enough that you might actually, I'm not going to say stop lipolysis because that would go against what I've said, but definitely make it less efficient in terms of you're going to expose more fat cells to more insulin as well. So that's just my theory. Energy balance rules, don't forget. So all this stuff was we're talking about maybe microscopic details in the bigger picture. So calorie balance first, then macronutrients. Okay, those are the sort of order you need to worry about. And like I say, because we know that resistance training increases insulin sensitivity and it's going to help with that uptake of blood glucose and make cells more sensitive, we need to get larger amounts around our training initially as well, okay? Even if, like I said before, you're dieting, keeping some carbohydrates around your training will help refueling, and it will actually help stop muscle protein breakdown without realistically having any detrimental effects on fat loss. Okay? So, why do many people swear by low-carb diets? Well, it's suitable in some populations, like I've said. In obese people, it might help improve insulin sensitivity. In women, if women have got estrogen dominance, there's interactions between estrogen and insulin. I'm not going to get too much into the mechanisms of these things because they are quite complex, but fundamentally, women who have high estrogen levels, they tend to have poor insulin sensitivity as well, so we might need to consider lower carb diets tend to work better for women than men. And always and obviously, some people do appear to just run better off higher fats. Some people prefer more fats in their diet. They feel better. They feel like they've got more energy. But we'll talk about one of the other benefits is that because you're going to drop a lot of weight quickly, initially anyway, you're going to get more adherence. So this is one of the philosophies why certain meal replacement companies, they recommend you do these 900 calorie diets, because you're not going to have enough glycogen in there, and glycogen holds water in the muscle. So for every gram of glycogen you have stored in a muscle, you get 3 to 4 grams of water. Okay, so if you're losing glycogen all the time because you're not restocking it because you've got no carbohydrates, you're going to lose water as well. So, weight loss of 8 to 10 pounds in a week or two is not unheard of. And people think, because they don't understand the mechanisms, that this is fat loss. So regardless of why the carbohydrates are missing from the diet, B, because it's a low-carb diet or a ketogenic diet, or B, because they're getting these meal replacement shakes or products which are very low in carbohydrate overall, that's one of the reasons why people get this adherence as well. So, but long-term adherence then becomes problematic. Social eating on a low-carb diet is very difficult. For competitive athletes, physique athletes, you're going to want to keep some carbohydrates in there at least 1 or 2 days a week on a higher day, because your body will down-regulate its ability to store glycogen, which if you're then trying to carb up for a competition is going to make it more problematic for you to do so. So your blood glucose isn't going to clear. You know, you're going to put a lot of stress on the body through that as well from a dietary perspective, and also in terms of a carbohydrate intake perspective as well. So even if you are going to go low carb, I wouldn't advise it just being low carb. I would put intermittent refeeds in there as well. Maybe have 1 or 2 higher carb day a week. So even on a weight loss program, it doesn't necessarily have to be a carbohydrate amount that you're going to be in energy surplus, but definitely one which is going to actually help restock some glycogen, even if you need to drop fats out a little bit those days as well. Okay. Also, you've got to remember that fats and protein are satiating, so they make you feel the fullness. The question is as well, a big question I have is feeling full enough? Okay. By this, what I mean is your body will naturally crave what it needs. Okay, so if your energy levels are low, and yes, you can get energy from proteins and fats, we've discussed that, but if your blood sugar starts to drop, your body will crave sweet things. It's a natural product as well. So that's why I always prefer a balanced diet, because you're less likely to get these cravings and these impacts that your body is asking for a certain nutrient supply, because like I say, survival is your body's key driver. You know, it doesn't care about your weight loss, it doesn't care about your muscle gain. What it cares about is surviving. So if your body's blood glucose levels are dropping or they're struggling to maintain, your body's going to crave sweet things, and it can be very difficult to maintain that in the long term. So a balanced diet for most people, in terms of a good amount of protein, a higher amount of protein would usually be recommended, I would suggest. We've talked about those amounts. With a good amount of fats, at least 1 gram per kilogram initially. Some people might be a little bit lower, a little bit higher, depending on how you feel. And then the rest from carbohydrates will be enough then to provide those processes, like we've said. Like I've said before, it is a socially challenging diet strategy. Go to any restaurant, any chain, any franchise you want, and try and order off the menu something which is low in carbohydrates. Recently went to a chain, a steakhouse, and even then, yes, you can have steak and a green salad, but usually it will come with some kind of dressing. Usually there'll be some form of, there'll be some sort of side with it as well, and having them sat on a plate, even if you can't have them, can be quite challenging. People have desserts, people will start to question you, there's that peer pressure, that social pressure then to eat more normally, because, it's like, well, what's one dessert going to do if you're not eating carbohydrate all the time, and so on and so forth. It's easier and more sustainable to keep carbohydrates in the diet and factor them in, and not be frowned upon or not be looked at like a weirdo, I guess, than it is to have them out. Okay, so even within someone dieting who goes out to eat for a special occasion, yes, you might have to be aware of what you're eating and try and find what's in those foods, but it's a little bit less restrictive than, say, a purely low carb diet. Okay, and like I say, most low carb diets are unsustainable in the long term because of that context. So therefore, what people do, a really important one on this one, is people then, because they've made good progress, associate eating carbs with failure or guilt. Okay, so you're going to develop, with any restricted diet that restricts any macronutrient, be that fats or be that carbohydrates, basically people are going to develop emotional attachment to those foods, and I think that's why eating carbohydrates within a diet and having them, or if a low carb diet, having them now and again, is going to actually train that person to not have a negative association with that food. Because the last thing we want to be giving people when dieting them, or just trying to help them lose a bit of weight or even build muscle, is we don't want them to develop negative associations with food. So one of the best coaches I know are also the best counselors and the best psychologists. Okay, they have that trait within them to actually develop positive relationship with foods and not force negative ones as well. I see it all the time. I even speak to people with, I guess, my background and my level of understanding of the science behind these things and a very balanced view, I think. But I will still speak to people who will come for my input and my advice, and I will tell them they need to eat more carbohydrates, and they just won't do it. It doesn't matter who tells them. It's just been so drilled into them that unless you get to have that trust with that person, and it takes time, and it might only be 5 grams of carbohydrates a week, every 2 weeks increases on what they're normally eating, but you have to take that time to develop those things. So if people are struggling with that, it can be an emotional issue as well. So don't just think that they've got, it sounds awful to say, but they've got some kind of like eating disorder or food issue, because most people, I guess, working within this industry, or people who train or want to lose weight, have some emotional relationship with food, either for overeating or avoiding certain nutrients as well. So yeah, develop your psychological skills, develop your, I guess it would be in the medical terms called bedside manner, and that way you'll become a more successful coach. You'll get more adherence, you'll get more trust, and you'll get better results for that process as well. Okay, so hopefully that's give you understand about how glycogen is formed and broken down. So now we know what happens to carbohydrates. We've talked about those pathways in terms of energy production, either anaerobically or through the Krebs cycle, and now we know how it's stored as well. So we'll talk a little bit now about dietary fat. And one of the things you'll see a lot about in the literature or lack of in literature, not so much scientific literature, but definitely in fitness industry literature, is that fat and lipid metabolism is actually very poorly understood. It appears that there's different fates to the different fatty acids we eat. So within your module text, you'll see there's different fatty acids and they perform different functions. And each one of those has different health and potentially energy implications as well. So, there's certain fatty acids that are involved in shuttling nutrients into energy into mitochondria that are essential and have benefits for fat loss potentially. There's ones that are important for cell signaling, and then you've got structural fatty acids, and then obviously ones for energy as well. So without getting too much into it, one of the things that does frustrate me slightly is when people talk about fats, and when we talk about macronutrients and things like IFYM diets. Yes, carbohydrates, proteins, and fats are important, and the ratios of those in the diet and the amounts of those in the diet are important. But in terms of fatty acids, if you're not paying attention to where you're getting those sources from, you can still not be a healthy person yet still be eating under calories, still be getting enough fat in the diet as well. So I've outlined some of the risk factors of having certain things like too much saturated fatty acids in the module text, but even within that, there might be certain specific types of saturated fatty acids that are worse than others as well. So if you're interested in that sort of thing, there's plenty more reading to do around that subject. It's something I'm still personally learning about a lot. But ultimately, it's very poorly understood, and that's why it's very rarely written about in any kind of deep and meaningful way. People just tend to talk about, people will talk about carbohydrates in terms of, low GI, high GI, so on and so forth, and the different types of sugars there are. You'll see people talk about different amino acids like glutamine, leucine, so on and so forth. When people talk about fatty acids, the two you'll really get is saturated and unsaturated. And if you're lucky, people might talk about things like omega-3. But ultimately, that's it. And there's a lot of fatty acid strains out there, chains out there that are just very poorly understood in terms of their physiological function. But a basic pathway from food for fatty acids is obviously it's digested, absorbed, and then packaged. So whereas carbohydrates can be taken directly into a muscle cell, or liver cell, for example, under the action of insulin, what tends to happen with fatty acids is that they are packaged into things called chylomicrons. Okay, and these are packaged in the liver. So you have your sort of hepatic circulation. So fatty acids are absorbed slightly differently. So they're absorbed into the bloodstream, then they're packaged in the liver, and then they can either be stored as adipose tissue, so travel around the body until it reaches a fat cell, stored as adipose tissue. It can be oxidized for energy, or it can perform one of a myriad of functions. So like we talked before, so various structures and signaling and so on and so forth. So another one of the most important questions is, well, does fat being released from a cell mean we are losing body fat? No, if the influx into cells is greater than the breakdown leaving cells. So what I mean this is where insulin comes into it. So if insulin is released and insulin binds to a specific cell, a fat cell let's talk about, then fat is not going to be being released from that cell. It inhibits the release, it causes storage. However, if I have low insulin, then there's a chance that my fat cells are going to be releasing energy, but that's still going to be dependent on the demand for energy within the body. It's not just going to come from nowhere. Just because there's no insulin doesn't mean cells are going to release energy unless there's some kind of signal for them to do so. Okay, so these aren't closed loops. We have a lot of complex signaling systems in the body which drive these processes. So, but let's say, for example, that even if that wasn't the case and fat cells are releasing fatty acids, okay, so our fat cells are shrinking, our adipose tissue is shrinking. If we have a large amount of fatty acids in the diet, where are they going to go? So if we consume more calories than we're burning from fatty acids, where are they going to go? They can't just sit in the bloodstream, or if they did, they'd raise blood triglycerides, which could be potentially very damaging to you. So they have to go somewhere. So there are, and this is what I'm saying about it being poorly understood, we know that fatty acids will clear, so they have to be being undertaken into some cells. Now your liver can take some, your muscles can take some, but if you've got a high amount of fats in your diet, there's an absolute certainty that that is being still stored as fat tissue, so as adipose tissue, okay? There are a few mechanisms which are proposed into which to do that. However, like I've said, it's pretty poorly understood, these transportation processes, but there are mechanisms that exist, okay? So anytime energy can enter into the Krebs cycle, there's a capacity for it to be shuttled and stored as fatty acids. We know this to be true. Okay. So when people say, I heard an argument, someone say the other day that you could just eat as much fat as you wanted and you wouldn't get fat. It's difficult to eat that amount of fat because, fat's quite filling. If you're trying to restrict your carbohydrate source as well, assume you're not talking about oils, you're talking about things like nut butters and stuff, you're inherently going to reduce your fat intake, because some of those fat sources do contain carbohydrates as well. Okay, so I don't have a problem with low carb diets, sort of high fat diets, but just be aware that it's the insulin thing isn't the main issue. So we'll talk about that again in a second. And it's one of the biggest misconceptions is that people seem to be able to have a free for all where you can eat as much protein as you want and as much fat as you want, and you won't get fat. You still have to maintain energy balance. Protein works slightly differently, like we've discussed, because protein, in essence, if you can stimulate muscle protein synthesis, causes a demand for energy. So you can have a bit more protein in your diet, and actually that can help with fat loss, assuming you're not going, again, excessive amounts, okay? But like I say, excessive amounts of protein have its advantages, but it'd realistically be pretty much impossible to get fat off eating protein alone, but you'd be very unhealthy because you'd be missing out on fats in your diet. You'd be underperforming because you'd be missing out on carbohydrates. And although we know that we can produce glucose from non-carbohydrate sources, it's just not a particularly efficient way of doing things, or effective way, really. We can't do it at the rates that we would demand as people who are training. So, like I say, remember energy balance. So for some people, they might prefer higher carbs, lower fats, higher carbs. As long as we're getting enough essential nutrients in there, enough essential macronutrients, and we're getting on micros as well. Where you get your carbs and fats from is very individual. Like I say, some populations might prefer to have more of a low carb diet, particularly those who've got poor insulin sensitivity. But for most healthy people with normally functioning insulin sensitivity, then yeah, I think it's a misconception that you can just eat as much fat as you want and still stay thin. This might seem like, to some of you, like an obvious thing that you still need to account for calories, but for so many people, there's so much food confusion. And like I say, there's a lot of proponents of certain diets which will just give you a free-for-all to eat as much fat as you want. You will still get fat. So here we are again at our blank white slide, which notes the end of our presentation. So that's 8 of the modules done now. So we've got one more module video to do with the main content, the sort of broader content, before we move on to the sort of Y3T specific stuff. So you'll learn about Neil's methods and why he likes to do the things they do, and some of the science that supports the philosophies of the training system. Okay, there are many different training systems out there, and there's many advantages and some disadvantages to them as well. So we're going to discuss some of those things as well, and things we can look out for. But for now, I'd like to thank you again for watching this module video. Next module is a personal favourite of mine, because it's the thing that got me started in this industry, was talking and writing about supplements, because that's where I started working in this. For my PhD, was working in the supplement shop many moons ago now. So yeah, I know quite a lot about supplements. So we're going to talk about the good, the bad, and the ugly supplements. That will make more sense. But I'd just like to thank you again for listening. Any questions, as always, drop me a message on the Facebook group or through email, and you will hear from me next time you click play. Happy learning.